Okay, good morning, guys. So today is another day, and electrolysis is the topic. So let's take it uh as comprehensive as possible. Okay. So moving on. So introduction to electrolysis. Electrolysis basically as a concept in science or in chemistry or in physics, as the case may be, is just from like two words now, she get electro and lysis. I mean now, so just like we are bringing in electricity and what lysis, where lysis means breakdown, she get. So the electrolysis basically is now the breaking down, the decomposition of what of chemical compounds using what electrical current. She get. So you are using what electrical energy, you are converting it to what chemical energy. You are converting you are using an electrical energy to cause a chemical reaction. Or what's the chemical reaction? Decomposition. So this process involves the composition of compounds by passing an electric current through them, so causing ions to move towards the electrodes. She get. So then electrolysis is the process which converts electrical energy into chemical energy. Very important to note. Then the process of electrolysis has many practical applications, including the metal refining. That's like metal refining is actually referring to what? Purification of metal, basically. Electroplating, like for example, take a banana for example. What you eat in banana is like it's like the real metal, then the this shell, or let me just say the cover, anything that as you understand it, will be what we plated banana with. So we plated banana with that shell, shey you get. So we can also use electroplating now to plate a metal with another metal, shey you get. Those are the use cases when they are plating iron with gold. They are making iron look like gold and the likes. So that's electroplating. So the production of chemicals such as chlorine, sodium hydroxide and co. So that's also very important. So okay, now moving on. So what's the science behind electrolysis? So electrolysis is based on the principle of electrochemistry, which involves the transfer of electrons between atoms or molecules. So when an electric current is passed through a solution of molten material, it causes the ions in the solution to move towards the electrode, where they either gain or lose electron. That's the idea. So ions will move. We are going to discuss the electrodes, the electrolyte, and co. But just try to get the overview of it now. Then the electrolysis process can be used to decompose compounds, depending on their reactivity and the conditions under which the electrolysis is performed. That's very, very important. For example, the electrolysis of water can be used to produce hydrogen and oxygen gas, while the electrolysis of brine is concentrated sodium chloride, can be used to produce chlorine gas and sodium hydroxide, depending on what you are using, depending on the reagent you are using, depending on the compound you are using, depending on the condition. Is it dilute one or concentrated one? Is it are we using a reactive electrode or an inert electrode? All those things they matter. So that's just the idea behind this. So advantage and disadvantage of electrolysis. The guy has a lot of advantages, and it's most of the time an industrial process. You don't perform electrolysis in your laboratory like that. Shey get. Although there are some use cases of electrochemical reactions around us, like corrosion. Corrosion is an electrochemical reaction, but majorly when you are using electrolysis, it's an industrial process to produce, to purify, to electroplate and all those stuff, metals. So one of the main advantages of electrolysis is that it allows for the production of pure metals, that's purification, and chemicals that cannot be obtained through other methods. Additionally, electrolysis can be used to recycle metals and other materials, that's purification and all, reducing waste and what conserving resources. But if you are not talking about the disadvantage now, is a whole lot expensive process. It consumes a lot of energy. Yes, it consumes a lot of what electrical energy in this case. That's just the idea. So electrolytic condition. So conduction rather. Electrolytic conduction. Electrolytic conduction is just basically don't forget we are using electric current here, and the electric current is going to pass through something, right? So that thing is going to pass through is actually going to conduct it. I mean, that's conduction. So when I'm not speaking of electrolytic conduction, it's just like the conduction of what electric current in an electrolytic setup, in the sense of okay, we have the anode, cathode, and electrolyte. Electric current is passing through them. So you get that's electrolytic conduction basically. But most of the time is what referring to the what electrolyte alone. So we are going to see what an electrolyte is now. So this type of conduction is exhibited by compounds, acid base and salt. and can break up into cations and anions. That can break down into cations and anions. Yes. Compounds like covalent compounds that cannot break down into their ions because they are not ionic. So you get those guys are they will not be okay in this kind of electrolytic conduction because it is a property exhibited by just the ionic compounds alone. Ionic compound in the sense that of those that can what dissociate into what the um what do we call it now, the cation and the anion into the two ions. So but for your electrolytes now, that means the one that is actually ionic. Shey you get the conduction can now be in two cases or two conditions. Number one, is it is the electrolyte is the compound dissolved in water, is the ionic compound dissolved in water. If it's dissolved in water, that means they are going to form what? An aqueous solution. So and when it is dissolved in water, the individual ions dissociates. That's another thing to note. So that's that for that. Or is it in the molten form? For example, let's take sodium chloride for example. You can put sodium chloride in water and you can also melt sodium chloride. When you put sodium chloride in water, sodium chloride will dissociate. When you melt it, it's going to dissociate. Shey you get. So, but in water, the difference will now be that when you put it in water, sodium chloride is going to dissociate to give me sodium and chlorine. Yes, sodium and chloride ion. Then water itself will also now dissociate because something is actually dissolving in it and ionic compound is dissolving in it. So you are not going to have hydrogen and what? Hydroxide ion. So we are having four ions in the case of what? When it is dissolved in water. But in the molten form now, in the molten form, that's when you are just because it's only sodium chloride. I only melt it. It's a physical change. So I'm only going to have sodium and chloride ion alone. So the carriers of electricity in compound in this case is what free mobile hydrated ions. She gets they are just ions. That's just the idea. It is ions that is carrying your electricity in what in electrolysis. So the compounds that conduct the electricity are referred to as what? Electrolyte. Very simple. So based on the degree of ionization of electrolytes, we cannot have what? The strong and the weak electrolyte. Just like we have strong and weak bases. So there or an acid. Strong acid will be a strong electrolyte. Weak acid will be a weak electrolyte. Strong base will be a strong electrolyte. Weak base will be a weak electrolyte. That's the idea. It depends on how much can you dissociate in what in solution or in the emulsing form. So the difference between a conductor now and an electrolyte is that a conductor is like an element. Like iron is a conductor, zinc is a conductor, the metals on the periodic tables are conductors. While electrolyte is a compound. So you get that we have to break down. It's going to form ions, then the ions will now be the one conducting, helping us in the conduction. That's the idea. So your conductor uses electrons, free mobile ones, as carriers of electricity, while your electrolyte is using what? Ions. Then the last one here, you don't expect zinc to undergo decomposition before it conducts. Why your electrolyte you definitely need to undergo decomposition. If you don't, the okay, then don't let me call it decomposition per se. Let me use the word dissociation. So you get so your electrolyte will need to undergo dissociation for it to actually do that. Okay, so let's now go deeper into electrolysis. So electrolysis is a process that converts what electrical energy to chemical energy. I've explained that earlier, and it involves the decomposition of an ionic compound by means of electric current passed into the aqueous solution or molten form of the compound through conductors known as what? Electrodes. Yeah. So electrodes, we've mentioned electrolyte, we've mentioned the old electrolysis, we've explained everything. But we also now need to know that there are electrodes. Just like we have for a battery, there are what terminals, like positive and negative terminals. For you to pass, for an electric current to pass through something, it must enter through somewhere and also leave through somewhere. It's kind of like a cycle actually. It must enter through somewhere, then leave through somewhere. So where it is going to those terminals where it's entering through the entrance and the exodus, the exit of this of the electrolytic setup. So you get the entrance and the exit, they are the what electrodes. That they are referred to as electrodes. So the decomposition involves a non-spontaneous redox reaction. Yes, it is non-spontaneous in the sense that without you passing the current, they won't do anything. The reaction will not occur. So you get it is non-spontaneous. So when the reaction now starts occurring, that means we forced it. In fact, some people say it is a forced spontaneous process. They forced it. You get. So when after the thing is now occurring already, it is always not kind of a redox reaction. Electrons are being transferred. That's just the idea. So and when they say something is non spontaneous, you need to also know that your Gibbs free energy is what is positive. Okay. So then an electrolytic cell. So an electrolytic cell is a device that uses electrical energy to drive non-spontaneous Chemical reactions, yeah. The cell consists of two electrodes, the anode and the cathode, immersed in an electrolyte solution. When a voltage is applied across the electrodes, electrons flow from the anode to the cathode. That means electrons will enter where now? Through the what? Anode, then to the cathode. Through an external circuit. While ions in the electrolyte solution move in the opposite direction to maintain charge neutrality. You are still going to get this better. The electrolytic cells are used for a variety of industrial applications, including electroplating. We talked about this before. Okay, so the electrodes now. Let's talk about the electrodes. I already mentioned the two guys that we have, the anode and the cathode. Sure you get. So the idea is just that the anode is what is the positive guy, the cathode is what negative guys. I think it is reasonable because cathode is kind of catabolic. It breaks down. It is negative. Is you get my point. So anode and cathode are two essential components of an electrochemical cell. They are responsible for the flow of electrons in the cell, which is essential for generation of electricity. Very important. Then the anode is the electrode where oxidation occurs. Why cathode is the electrode where reduction takes place. Yeah. So I need you to understand. Just take this mnemonic. Kraho. Shall you get? So your cathode is reduction while your anode is oxidation. You should never forget this statement. They will ask you. Yeah. So an electrolytic setup, in an electrolytic setup now, the anode is known to be the positive electrode while the cathode is the negative electrode. Yeah. I just mentioned that. Then according to the law of electrostatics, positive like charges was to repel and like charges attract. That means for to the positive electrode now, the ions that will go there will be negative. While to the negative electrode, the ions that will go there will be what? Positive. That's the idea. So positive ions will migrate to the negative electrode cathode. Hence they are called what? The cathode ions, cations. While the negative ions will now migrate to the positive electrode, which is the anode. She gets so ions that now migrate to the anode that was they are the anode ions. That's what anions. So moving on. So the anode now, which is the positive electrode. So these guys take electric current from the power source to the electrolyte. It takes electric current from the power source to what to the electrolyte. Hence, it attracts negative ions. Very, very important. So your electric current enters through what now through the anode. And one thing I need you guys to understand here is that the current and the electron. Don't forget when. Let's just put it this way: the current and the electrons that are moving. Electrons are actually also moving. So you get the charges. Let me just put charges like that. They are in opposite direction basically. So you get if current is entering to the anode, that means the charge or the electron is electron. Let me just put it electron basically. Electron is leaving through the what? Through the anode. Please note that. Don't forget in your electrolytic process there are transfer of electrons. So you get. So if your current is entering, in fact, it's not if your current now, the current is entering through the what? Through the anode. That means your what? Your electrons, she gets your electrons are what leaving through the anode. So while the current is leaving through the anode, the electrons are entering through the cathode rather. Let me take it again. I think I mixed that up. So your current is entering through the anode, electrons are leaving through the anode. So your current is leaving through the cathode, electrons are entering to the what? Cathode. That's just the idea. So for your anode now, oxidation occurs there, you know that already. Then the solution occurs there. So let's take for example when you're talking about oxidation. If I oxidize sodium, I'm going to form sodium ion. And sodium ion is always in like an aqueous solution. So you get that's like it dissolves. That's just the idea. I want you to get it that way. So in your anode, the solution occurs. That means your anode keeps dissolving. That's just it. That means to be reducing in size. That's just the idea there. And to the cathode now, the electric current from the electrolyte, it carries the electric current from the electrolyte back to the power source. That means the electric current leaves the arena while the electron will enter. Simple stuff. So it attracts positive ions, reduction occurs there, deposition occurs there. So if we are I'm actually when the last one I mentioned here, dissolution occurs there. This dissolution is in the case where okay, I say in the case of reactive electrodes, shey you get there are some electrodes that are not reactive that are what inert. They will not dissolve, they will not do anything. So in the case of a reactive electrode now, the same thing also happens to cathode. So instead of the cathode dissolving, the anode that is dissolving will be depositing there. Shey you get it's like we'll be plating it. That's actually the process we're using what electroplating. So we are going. I'm going to give you guys an assignment on this now before I forget. So explain purification and electroplating and give me the differences. Drop it on the group before 6 p.m. today. Yeah. So explain electroplating and purification. If I tell you guys now, you're going to forget. That's just the idea. So explain those two processes and then list the differences between electroplating and purification of metal. Shake it. So then in class we are going to take a deep deeper dive into it. Yeah. So let's move on. So electrolytic process now. So what actually happens in electrolysis? It is actually three things. When you have your electrolytic setups, we are expecting three things to happen in three different steps. Shege. The first one is what? Ionization of the electrolyte and water, one, or the ionization of the electrolyte alone. Let me edit better and make the other guy also bold. Yeah, just for easy readability actually. Where are we? Yeah, so this guy should also be bold. Okay, moving on now. So the ionization of the electrolyte alone, yes, very, very important. The ionization of the electrolyte alone is one thing. Basically, the idea I just want to get here is ionization occurs in what? In the first step. And during ionization, it can occur in two cases. Now, don't forget, our electrolyte can either be what? Dissolved or molten. So if it is dissolved in water, it is not only the electrolyte that we ionize, water will also ionize. I've explained that already. So let's say, for example, you have sodium chloride in water. Sodium chloride will give me sodium ion and chloride ion. Water will also give me hydrogen ion and what? Hydroxide ion. But if it is a molten something now, shey get it just be the what? Electrolyte alone. Because there's no water to ionize there. So example like okay for example now in aqueous CuSO4 that's CuSO4 dissolved in water. So CuSO4 ionizes, water also ionizes. But in molten PB lead bromide it's only the lead bromide that will ionize because there's no other thing to ionize there. So the ions produced here move at random within the electrolyte since the switch is not yet on like electric current is not yet moving. They're not the ions there, they are just acting like particles in a gas. Shey get they are just moving. That's the idea because we've not yet started the process. But because it is just in water yet, or maybe it is molted yet, ionization will just occur. So it's just basic ionization that occurs in the what? In the first step, in the first electrolytic what? Process. Moving on. The second step now is the migration of ions to the what? Electrodes. Migration of ions to the electrodes. So this occurs when the switch is on. Shey get. That means electric current is now passing through the anode and moving out through the cathode. The electrons are now moving through the cathode and what? Leaving through the anode. That means everything is happening already. So migration will now occur. Those ions that are dissociated will now start what? Moving to their respective location. Don't forget, I told you guys that the positive electrode will take the what? The negative ion, while the negative electrode will take the what? The positive ion. That's the idea. So the positively charged ion might go to the cathode because the cathode is what? Is negative. While the negatively charged ion might go to the anode because the anode is what? Positive. So like in the CuSO4 now electrolyte, given in the first step above for the CuSO4 aqueous here, shey get. So copper and hydrogen will migrate to the cathode because after it ionizes, don't forget copper sulfate ionizes, water also ionizes. So copper sulfate basically give us copper ion and water give us hydrogen ion. That means we have two positive what? Two positively charged ions there. So these two positively charged ions will now go to the what? Negatively charged electrode, which is what? The cathode. So this the same thing will happen to the what? To the SO4 2 minus and OH minus. They will move to the what? To the anode. That's what I'm trying to say here. So Cu2 plus and H plus will migrate to the cathode. SO4 2 minus and OH minus will migrate to the what? To the anode. Simple stuff. So to the last step now is what? The discharge of ions at the what? At the electrodes. Yes. So don't forget, in most cases actually, in most cases, um they will give you in the aqueous state. So if they give you in the aqueous state now, out of the two that will migrate to the cathode and the two that will migrate to the anode, it is just one that will be discharged. Shey you get. If it is in the molten state now, it is one that migrated to the anode, right? It's that one that will be discharged. But when we are now having two or three of them, shey you get. Although it's not so common that you have three, shey you get. But if you're not having two of them now, that means one will bow for the other one. That's just the idea. So and in that case now, there's also now rules that will follow. So in the case of the lead bromide, don't forget it is just lead and bromine. So lead will be discharged as the what? As the cathode as the lead metal. Let's look at what happens to the lead at the cathode. What happens to the lead at the cathode? It gains two electrons, which is what? Reduction. While at the anode, bromide lost two electrons, that which is what? Oxidation. Simple stuff. I forgot to put this is oxidation. Let me quickly do that. Uh, how's that? So that's that on that now. So that's oxidation, then that's reduction. So the discharge of ions now it is not something that is just a play because we now have some guys tampering it and some guys not. She get. So for cases where two different ions have the same charge type, like positive and positive, negative and negative, migrate to an electrode. One of the ion is selected for preferential discharge. Like there is preference now. She get like, oh, this is what I want to be discharged. She get based on what we have. That's just the idea. So the selection of an ion for preferential discharge by an electrode is based on some factors. So number one, the position of the ion in the electrochemical series. That's it. So electrochemical series, okay. I don't want to assume. I don't want to just mention the electrochemical series I've given you guys. So electrochemical series is just the series of what of your metals in their order of their reactivity, like that, and their potentials too actually. So I want to try and get it and just drop it there. I'm almost there. Oh, this is a lot. I'm coming. Let me just look for a table instead so there won't be issue. Okay, I think this makes sense. Okay. No, 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 this is not what I want. Okay, this is it. Yeah. Okay, good. This is it. So let me copy this image and then just paste it there. No, this is not what I want to paste it. So when you now talk about the electrochemical series now, it's just basically a chart or something that shows what how reactive metals are. That's just another thing to take it there. It's kind of showing us how reactive metals are, and to understand that quite well, we need to get that. Okay, let me just show you. Hey, what's this? This is not what I want to. I'm coming. Speech. No, 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 that's not it. So okay, let's just quickly have this. It's something you can also check out. Shey you get. So just check out the electrochemical series. Yeah, but I thought I copied it well. Copy image. It's not coming in. So let's just move on. So number one, the position of the ion in the electrochemical series now. So electrochemical series basically is a series for metals. Or it's not just metals. Let me not put chain in my leg. It's not just metals. So for metals, we have metals and for what? Non-metals, basically cations and anions. Let me put it that way. Cations and anions. So for cations, we have um um potassium. I use the mnemonic, so you get. So let me just drop the mnemonic for the electrochemical series here. Let me drop it so that when you see it, you can just follow along with it. So you can use popular scientists can make a zoo in a low image country. I think this one is a little bit. There's a lot of mnemonic for this thing, so I'm trying to give you the simplest one. Yeah, King. This one is funny. King Nathan can marry all zombie female students, provided he can handle against authority provided. So this is the idea we have here. So wait, I hope we are on that page here. Okay, yeah, you guys are seeing that I'm typing. That's fantastic. So King Nathan can marry all zombie female students provided he can handle against authority provided. Like that makes sense, right? Like King Nathan, oh, you want to marry all the zombie female students. That means you should be able to handle against the authority that we have. That is the idea. Although the one I use majorly is Kofi na can manage or Kofi na can manage all zinc for some people having copper, mercury, silver, gold, and platinum. So this second that I'm using is actually not the easy one because I'm still mentioning copper, mercury, silver, gold, and platinum. She get, but the first one is actually a perfect mnemonic for this. But as per this was the first one I learned was the coffee, so I don't really forget that at all. But you can also use that. Coffee now can manage again for some people having copper, mercury, silver, gold, and platinum. She get. Why for the king Nathan now? So basically, the king there is what is the potassium, Nathan is sodium, can is calcium, Mary is magnesium, all is aluminium, zombie is zinc, female is iron, student is tin, provided is lead, E is hydrogen. Hydrogen is like the base there because the potential of hydrogen is zero. So that's like the reference point. So can is copper, hydrogen, copper, yes. Then Andrew is mercury, against is silver, authority is gold as per age, then provided is platinum. So this is now like okay, we already know what we have here, but they are in their ionic state actually. So that means king, although there's lithium before king self, so you get, but that one is in activity series. But the electrochemical series, there's no lithium. So king is like the first one, yeah, so you get that, which is potassium, and platinum is the last one. So when you have, let's say, potassium, okay, let me use sodium that is common. Sodium and hydrogen, this hydrogen here. Do you see those two guys? So we have king nathan, which is sodium and hydrogen, and they both move to the what? To the which electrode now? They are positive ions, so they will move to the what? Negative electrode, which is cathode. Abina. So that means which one will be discharged between these two guys? That's what the first one is telling us. Position of the ion in the electrochemical series. So you get, so because, and this is actually it. As you move from king to provided, she get, the preference for discharge increases. That means hydrogen will be discharged over sodium. As you are going downward, you have more. In fact, this is the idea. Use lower energy to discharge the lower guys. She get, and who wants to waste energy? That's just the idea. So you just go for what? Hydrogen, the lowest guy, lower guys. So, but in our question, in the question we have there, in the question we have there, this particular question, this one now, copper and hydrogen, which one will be discharged? So for copper and hydrogen now, for copper and hydrogen, we have what? Um, King Nathan can marry us if you see them provided you can do against. Where's copper? Copper. Okay, this copper, this hydrogen. Do you see that? Copper and hydrogen. Although copper is after hydrogen, she get, copper is after hydrogen, and they are very close. Copper will be discharged there. That's the idea. Copper will be discharged there. But if you have more hydrogen in the solution, we are going to see that in the next one. So these ones are for cations. Okay, let's look at the one for anions now. For anions is the mnemonic is not common, so I'm not so sure you see the mnemonic online for it. But the one I first used then is a little bit tricky. Let me just give you the basic one that is popular now. So the basic one that is popular now is just food seller, no collect drive in Oyo. Like we know they collect drive for your state, that's it. So food seller, fluorine, food is fluorine, seller is sulfate ion, fluoride ion, sulfate ion, nitrate ion, chloride ion, bromide ion, iodide ion, and hydroxide ion. Shey you get? So okay, I'm tempted to actually give you the ions. So K plus for the this for the anions, Na plus, Ca2 plus, Mg2 plus, Al3 plus. I cannot be putting those charge on top to waste time. Then Zn2 plus, Sn2 plus. Although there's also Sn4 plus, there is, you have that. In fact, Pb2 plus, there's also Pb plus 4 plus, Pb2 plus, but that's are the common one. Then H plus, there's nothing like H. Although there's H minus, yes, there's H minus, but you may not see that in this level now. Just in biochemistry, I saw that too. There's H minus, and H minus will be when hydrogen actually has two electrons in the outermost shell, which is kind of like not reasonable enough. But it will happen if hydrogen is bonding with a what? A less electropositive something. That's just it. And it's almost impossible, but it happens too. So we have H plus, we also have copper Cu2 plus, we have Hg plus, Ag plus, Ag plus, then Pt plus. That's that for this. Then for the anions, F minus, SO4 2 minus. I have to use this. Then we have O3 minus. Then we have Cl minus. We have Br minus. Then we have I minus. Then we have OH minus. So these are the what electrochemical series, this is what we are going to be using. Shey you get. So if you have aluminium and hydrogen, automatic and this is mercury. If you have aluminum and mercury, you automatically know that what mercury will be discharged. Shey you get. It's the one that will be free out of the solution. It will come out as what a mercury metal. And don't forget, mercury is the what is the only liquid metal. It is the Indaboski of the metals kingdom. Indaboski Bahoshi. You know the liquid metal. That's it. See, liquid metal is what mercury. Then for full cellular no correct bribing or now. So fluorine is starting it. So if you have fluorine and hydroxide in a solution, fluorine and hydroxide, so hydroxide will be what will be released. So you get in form of water and oxygen actually. So that's just the idea on that. Then the second thing now, the second factor that affects the second factor that affects is what we know as the concentration of the electrolyte. That's just the idea. So everything that you already know here, it is valid actually. Shey is not wrong. But imagine when you have okay, let me take this and this chloride ion and hydroxide ion. So you get normally hydroxide ion should be discharged, but if you now have it in a way so that chloride is more than hydroxide, in the case of maybe concentrated sodium chloride, so you get that means the sodium chloride is more than the water. That means the sodium ion will be more than the hydrogen ion, while the chloride ion will be more than the what hydroxide ion. So and because they are also very close to each other, so you get chloride ion will be discharged. But in the case of sodium chloride that is concentrated, we still have what sodium and what hydrogen. Sodium and hydrogen. So in because sodium and hydrogen they are very very far. Look at the distance between them. It's a lot of distance. Shey you get. So it is still hydrogen that will be discharged there. Shey you get. For the if, although sodium is more than hydrogen, but they are still very far from each other. So I will the cell will prefer to just discharge what hydrogen ion instead. So that's where the concentration of electrolyte comes in. So it is just reversing what we know here when the distance is very close between the two ions. Then the nature of the electrode. This one is like as per we are in Nigeria, shey you get. There's always being biased. So it is when they are being biased. For example, what is supposed to be discharged is not discharged. Shey you get. For example now, um when you use yes when you use platinum electrode in a reaction between maybe sodium and hydrogen that is going to the cathode to the anode now, sodium and no to the cathode, positive will go to the cathode, yeah, sorry for that. So when you have sodium and hydrogen and that is going to the what to the cathode, normally hydrogen should be discharged. So you get if you use your platinum electrode, hydrogen will still be discharged, but if you use mercury electrode, it is the sodium that will be discharged because it is easier for mercury to just take sodium while it is not easy for mercury shey you get. It's just like it's just like being partial. Shey you get. Some guys have love for other guys. That's just the idea. And also imagine a case where the electrode you are using is also one of the ion. You cannot expect me to see another femz outside there and now say I want to forsake the femz. It does not make sense. So I have to kind of favor that FMZ too if maybe they are into a fight or something. That's just the idea. So imagine I have the copper. Copper is the electrode, and copper is also in the ion. My brother, my sister, it is copper that will be discharged no matter what. Like no matter the matter, na copper. So that's just the idea. So you can know the one of if they have the same this thing, but the one of affinity most of the time they won't ask you. So moving on to the next thing now. So moving on to the next thing, we've talked about all this. So application of electrolysis now. So I think electrolysis generally I've explained it before. So it has many practical applications in industry and everyday life. One of the most common use of electrolysis is in the production of reactive metals. Yes, I saw it online that they say production of metals. You cannot use electrolysis to produce just any metal. Like it is not possible that you say okay you want to use electrolysis to produce mercury. No, it does not make sense. Or you want to use electrolysis to produce gold. No, you what it is for reactive metals, shey get. So then the reactive metals in the sense of um sodium, aluminum, that are leading, those guys that are leading in the those guys that are leading on the periodic table. So I said periodic table, those guys that are leading on the electrochemical series, shey get. So those are the guys that they are going to that you can use electrolysis to prepare them. Shey you get. That's just the idea. Then for the we also use it in purification. Shey you get. Purification in the sense of maybe you have a blistered copper, and I've given you assignment of purification and electroplating. So I won't talk about that. Then we also have what electroplating. So I don't know if that was over. Okay, yeah, calculations. Yeah, how did I forget that? So calculations basically. So this is one of the things I just love is this. So this is going to cover it actually, but it will be better, like way more better if you can just. It will be an interactive session, sure you get. So we are going to discuss this in our electrolysis class, sure you get. So the quantitative, which is the calculation aspect of electrolysis, is kind of guided by two laws, which are the Faraday's laws of electrolysis. And don't forget, Faraday's is like the father of electricity here. That's why it's in here. So, first law of Faraday's now states that was regarding to electrolysis, the mass of a substance liberated or deposited or dissolved at an electrode during electrolysis is directly proportional to the what? To the quantity of the electricity. So that's just the idea. Like the mass of something that is discharged is directly proportional to the quantity of electricity you use. So imagine if I use 10,000 coulombs of electricity and I use 20,000 coulombs of electricity, the one that I use more electricity will actually give me more mass that I needed. That's just the idea. So then you will notice M is directly proportional to Q, M is not equal to ZQ. So what's Z? So you notice that Z will be equal to what? M over Q. And that's what? The mass discharged per unit coulomb. M is the what? Z is the mass of a substance discharged per unit quantity of electricity. Shey you get, which is the unit coulomb. That means if you use 1 coulomb, what mass of that guy will be discharged? Shey you get. So different substance with different what? Different ions, different metals basically, or it's not just metals now. Shey you get different species, different areas of you get my point. So on the electrochemical series, they have their own what? Z. They have their own electrochemical equivalent. Sure, you get that's the Z. So and for the one that okay, if I use 1 coulomb of electricity for sodium and I use 1 coulomb of electricity for potassium containing salts or compounds, they have different electrochemical equivalent, different mass will be deposited. That's just the idea. So the mass that 1 coulomb will deposit for a particular substance is the electrochemical equivalent of that substance. So the quantity of electricity in coulomb is the product of okay, that's Q equals IT. That's just a basic thing which you should know already in physics. So then 1 Faraday is equals to 96500 coulombs. That's very important to note. And is there anything about that? So they can and 1 Faraday now, yes. So 1 Faraday is the quantity of electricity that can be measured. 1 Faraday is the quantity of electricity produced by 1 mole of electron. Yeah. For example, now, if I want to produce sodium metal now, for example, now Na, don't forget sodium Na plus is going to become Na by what? Gaining 1 electron. So that means it is the guy for one Na that is 23 grams now, is going to become the metal by gaining how many electron? 1 mole of electron. Shey you get? That means for me to produce 23 grams of sodium now, sodium needs to gain 1 mole of electron. And that 1 mole of electron, we need how many quantity of electricity, how many coulombs? Then it's 1 Faraday. So 1 Faraday is equal to 1 mole of electron. 2 Faraday is 2 moles of electron. That means for calcium, it will be 2 moles of electron. That means for oxygen gas, where you can produce oxygen gas, it is coming from, you can use O2 minus and it is 2 oxygen. Shey you get? That will be 4 moles of electron that will be lost. And that's what 4 Faradays. So that's just the idea on this. And then the second law is better off done with calculation, shey you get. So it is just that when you pass the same quantity of electricity two what? Two different electrolytes that are connected in series, shey you get. So you now say the moles of the element deposited or liberated are inversely proportional to the charge on the ions. That's just the idea. So for example now, if I pass don't forget let me use the first law to explain the second law. If I pass the same quantity of electricity now. Okay. For sodium, I said we are going to use what? We have okay, let me use sodium and aluminium. So for sodium, we are using 1 Faraday. For aluminium, we are using 3 Faradays. Abi now, look at that. Now imagine the 1 Faraday that I pass into sodium, I also pass 1 Faraday to aluminium. That means I will now have up to the molar mass of the aluminium that we produce because it is 3 Faradays that will give me the molar mass of aluminium. Sure you get. So that's just the idea. So the charge they have is simply proportional to their what? To their to the number of moles that will be deposited. That's the idea for that. And I think that's that. So thank you.